Hello, statistics student. This video is for chapter 9, in particular 9.1, 9.3, and 9.4, the basic of hypothesis tests. So hypothesis test is a important topics in introductory statistics. Basically, it is a tool, it's a procedures that help us to understand a population parameter by using a sample to test a claim. Okay, so instead of using what we learned in chapter 8 of estimating a population parameter, we actually have a hunch as what we want to prove or disprove, and we use the sample to make a conclusion as to a particular claim. And notice that the claim is about population, and the parameter that we study in this course is proportion and also mean. So we look at a categorical data. We want to claim that this particular proportion is of a particular value, greater than, less than, or not equal to, or not equal to a particular value. And we look at quantitative variable data, and we want to test that the mean value of this variable could be greater than, less than, equal to, or not equal to. Okay, so this is what we are planning to do. So to do that, we, of course, if this is statistics, we can do an experiment in the lab. We will collect a sample, and then we use the sample to prove or disprove this claim. To test this, we have two things that we need to set up. One is called the null hypothesis, and the other is called the alternative hypothesis. Now we have one claim, but we have to set up two hypotheses to start the process. Okay, so notice the claim is different from the null and alternative hypothesis. The null hypothesis, they're assumptions. They're used to do calculation, and they represent currently acceptable truth, usually is of equality, because if you don't equal to anything, you can't do any statistic calculation. The alternative hypothesis contain opposing view so that they don't overlap. And the big idea of making the assumption or like testing or making the conclusion is based on rare event rule. So when we get to the making conclusion, we'll talk about rare event rule. So basically, two things: null hypothesis, alternative hypothesis, and rare event rule. With the sample, you can actually test a claim. Okay, test a claim meaning we can say if the claim is true or not true. So the first is the process. So hypothesis tests, you could say it's very simple, but the process itself is quite long. I list it as 8 steps, but we can group them together so it's easy to remember. The first two is set up the hypothesis and the claim. The second is second part is 4, 5, 6 is actually do the calculation. If you according to the sample, use the sample and do some calculation. And this is when you actually do hypothesis analysis. In our case, we would use a calculator. So see, the last thing is use calculator to find something. And then the last steps is to make the conclusion to see if your original claim is correct or not. Okay, so basically like that. And in the last section, you would be using the rare event rule. So rare event rule say that if your sample is very rare, then you're surprised. So then you can say that, oh, I have something that is very significant. I can use it to make some conclusion. Okay, we talk about those in chapter 3 when we talk about probability. So probability is essential in making assumptions, making conclusions about this. So without delay, we'll start part A, which is set up the claim, set up the null hypothesis, and the alternative hypothesis. So to set up the claim is basically doing an algebraic translation of writing whether you're doing P or mu, and then you write down whether you want to do equal, greater than, not equal, or less than a value. Okay, so this is just documenting what you want to test. So most of the time we would test the bottom three, greater than something, less than something, and not equal to. So do you notice that we never, in inequality, we have actually greater than equal and less than equal? Where do they go? Can I test a claim on that? In some books, they allow people to do that, but if there is any equal, we group them as equal. Meaning we would say that is the extreme values of your P or mu. So if you say it is greater than something, so that means the greatest, or the least value it would have is equal to that. And if you are claiming that it is less than a particular value, the largest number at most it could be that. So whenever you see a claim being made on, at most or at least, or these kind, they're grouped number equal to include the extreme parts. Okay. So but in our book, I think they allow that, but in the more recent modern books, they get away with doing this. So some books allow you to do greater than equal. So if you see these happening in some books, just remember these represent just equal. Okay, this equal. Okay, B, the null hypothesis. Then we have, so after we write the claim down, then we have to set up two hypotheses, the null hypothesis and the alternative hypothesis. The null hypothesis is always equal because we use it to do calculation. And if it is a greater than equal, you would just choose the extreme value, which is equal. The alternative hypothesis is the second assumption that is opposite to the null hypothesis. So it would contain the bottom three. So it would be shown up here. A great test that you can do is, so how to make them is, write down x0 is always equal to the value that shows up in the claim. And then the alternative hypothesis would be either the claim, or if it is not, then it's not equal. If the claim is equal, then the alternative is not equal. Okay. So let's do some example to figure this out. It's a little confusing. So so let's say we claim that the body temperature is less than 98.6. So maybe everyone say that it is 98.6, but you want to claim that it is less than. So you write down your claim, right? It's just less than. And then you would write down x0 is equal, and then your claim would become the alternative, which is less than, right? So this is an easy one. So claim that the proportion of red MM is more than 10%. So some people say that, oh, we do not want that many red, so it should not be that many. It should just be at most 10%. But you say that, oh no, it is more than 10%. So your claim is you want to disprove it, so you're greater than 10%. Your alternative is greater than 10%, but your null is equal to 0.1. And when we write this proportion, we always write it in decimal. Okay. So whenever you see a claiming of a percentage, it's about proportion. The 3 and the 4 is a little different. So 3 would be claiming that the IQ score of college professor is different from 100. So we want to check that it is not 100. So we write it's not equal. Oh, the claim is not equal. It should be not equal. You write down. And then the alternative would be not equal to 100, so that the claim actually is here. But then null hypothesis is always 100. In the first three, you can see that you're almost 100% of the time, your claim actually is the alternative, right? So that's why it's called the research hypothesis. Is whatever that you want to do, you want to prove the status quo. Now the last one is a little different. You actually put forth an argument, and you say that the mean IQ score of college student is 105. Maybe someone has done this in the past, and you want to say that this argument is still true. So you see how your claim is equal. Your x0 is equal. So your claim is no longer in here. So this is quite rare. Okay, it is not what researchers usually do, but technically, academically, it's possible. So when this happens, the claim is actually in x0. Your null hypothesis is not equal. So it's not less than or greater than, but it will be not equal. So I usually, after I write it down, remind myself where the claim is. 90% of the time, or actually, in reality, a lot of times, 90%, you are doing when you're doing a research, your hypothesis is always the null alternative. And then your null hypothesis is always equal, which is not the claim. Except if your claim is equal, then the claim is actually X0. Does that make sense? Okay, so the good way to check is after you write this down, you ask yourself, where is my claim? Your claim has to show up. Okay, so you cannot have a claim that doesn't show up. So it's a mistake to say the alternative is greater than, because then the claim doesn't show up. Okay, so that's the first step. The second step is calculation. So we will go into more detail in 9.5 part 1 and 9.5 part 2 when we do a full hypothesis test. So for now, we just look at how we calculate. Notice X0, the null hypothesis, is our most important thing to do calculation. We'll forget about this for the time being. This is our assumption. So although you are claiming that, it should be not equal to that or greater than that or whatever, but this is our main assumption. So you use this assumption to do calculation. So the first things you do is you choose a significant level. Significant level, I hope you still remember, is what is being unlikely. The default is 0.05. But you can define it to be lower or upper depending on something called a type 1 error, which we'll cover in 9.2. So when you do 9.2, you'll know how you can get a better significant level. But if they don't say anything, it's 0.05. So assuming that you have collect a sample, then you need to know how you are going to calculate two numbers, something called test statistics and a p-value. What is a test statistic? Test statistics tell us how much our sample is away from the assumed value in X0. In X0, just like here, we assume that in all of them, we assume that P or mu is a particular value, right? So test statistics tell us how far away, how many standard deviation my sample is away from the assumed value. And then p-value is how likely I am to get that sample if X0 is true. So remember, in hypothesis tests, X0 is always the assumption, is assumed to be true. And if it is true, what is the probability of getting my sample? And then another term that shows up is types of tests. So because your alternative hypothesis can be greater than, less than, not equal to, so we have three types of tests that document the alternative hypothesis. One is called left tail test if you are talking about less than. Right tail test if your H1 has the form, or the alternative hypothesis has the form of greater than. And it's called a two tail test if your hypothesis is of not equal. So it's very easy. It's just a name. In some book, they call left tail and right tail one-tailed test or one-sided test. And this is called two-sided test also. And then how do I calculate those statistics and p-value? So remember, this two number is what is supposed to turn up after we have the sample. We cannot just look at the sample and know what to do. We would use a calculator to calculate. And to calculate it, we need to know what kind of distribution our sample is. So p hat, if we have a sample we collect, p hat is normally distributed, so we use normal distribution. If we have a sample about sample mean, then sample mean is normally distributed if sigma is known. But if sigma is not known, we use t distribution. So after we do that, then we will be doing our conclusion, right? So we'll talk about the conclusion in the next video.